Good morning. Today we're going to be talking about binomial expansion. When you multiply binomials, you have to multiply the first term by the second term. So you have to multiply the x minus 10 times the x plus 3. And in order to do that, first you have to break up the first thing. You have to break up the x and the minus 10. So it becomes x and it becomes minus 10. And you have to take both of these terms. You have to take the x and multiply it by the x plus, and you take the x and multiply it by the x plus 3. Then you also have to take the negative 10 and multiply that by x plus 3. So you multiply both of them like that. So in the first case, we have x times x gives us x squared, and then x times 3 gives us 3x. In the second one, we take the negative 10 and put it in here, and we do negative 10 times x gives us negative 10x. And negative 10 times 3 gives us negative 30. Then we combine the terms. We take the x squared, we bring it down here, and then we bring down the 3x, and we bring down the negative 10x, and we bring down the negative 30. We bring them all together. You can combine like terms. There's no other terms with squareds, so that just stays as x squared. However, this positive 3x and negative 10x, 3 minus 10 is negative 7x. So these two become negative 7x, so that your final answer is x squared minus 7x minus 30. So let's go ahead and try this next one. So again, we break it up into two parts. We take the x and put it here, and we take the negative 7 and put it here, and then we multiply them together. So let's go ahead and try this first one. X times x is 2x's, so it's going to be x to the second power. And x times negative 5 is negative 5x. On the other side, we have negative 7 times x, so it's going to be negative 7x. And then we just have two numbers. Whenever you have two numbers like negative 7 and negative 5, you just multiply them. And negative 7 times negative 5, a negative times a negative is a positive. And we know that 7 times 5 is 35. So then we just combine our numbers. We have the x squareds, and then we have this 5x and this 7x, and they're both negative. So it's like you owe someone money. It's like you owe someone $5, you owe someone $7. Altogether, you owe them 12, so it becomes 12x. And then you just bring down the 35. And that would be your answer for that one. You guys could go ahead and skip number 2 and skip number 3 because I accidentally wrote those problems. It's the same as the one up here. So you could skip those two because I accidentally put those in three times. So let's try number 4. This one says x plus 1 times x plus 4. So again, we split up this first one, and this becomes the x here, and we put the plus 1 here, and then we multiply them. So let's start by doing the x times the x. Anytime you do x times x, it's 2 x's, which means you have x to the second power. Then we do x times 4, which gives us 4x. On the other side, we have a 1, which makes this pretty easy because anything times 1 is itself. So this just becomes 1x, and 1 times 4 is plus 4. So for our final answer, there's only one x squared, so that's just x squared. And then we have a 4x and a 1x, and when we add those together, it gives us 5x's because they're both positive. And then lastly, we have this plus 4, so that just becomes plus 4, and that is your answer for that one. Try one more together, and then you guys can do the rest on your own. If we split this one up, we put the x over here and the negative 7 over here, and we multiply them both by x plus 7, because that's what we're multiplying by. So in this first one, anytime again, we have x times x gives us x to the second power. Then we do x times 7, which gives us 7x. On the other side, we have negative 7 times x, which gives us negative 7x. Then we have negative 7 times 7, which is negative 49. And we add this up together, we get x squared. 7 minus 7 is 0x. And then minus 49. And because we have 0x, those cancel out, and we could just write x squared minus 49. as our final answer. So what you're going to do is go ahead and try number 6 through 10 on your own.